Let's say I wanted to find the square root of a complex number. Say, for example, the square root of 3 plus 4i. So what I'm really wanting to find is z such that z squared equals 3 plus 4i. Now, because we know that z is x plus iy, then I can replace that with x plus iy squared equals 3 plus 4i. Expanding the left-hand side, the real part's x squared minus y squared, then the imaginary part is 2xyi, equaling 3 plus 4i. Now, the real part, x squared minus y squared, has to equal 3. And then the imaginary parts, 2xy, has to equal 4, or if you like, xy has to equal 2. So we need to find two values, x squared minus y squared equals 3 and xy equals 2. So simultaneous equations. So you can either solve that simultaneously, or if you look at them and by inspection, you could see that, okay, x would have to be 2 and y would have to be 1. But the other thing that also works is x is minus 2 and y equals minus 1. So the solution to the equation, the square root of 3 plus 4i, ends up being 2 plus I and minus 2 minus I. Now if you have a look at that, this is a complex number, so every complex number has two distinct square roots. If we call this z, then this is just the opposite, or if you like, minus z. And they are the two roots to the equation. That leads us on to solving quadratic equations that have got complex coefficients. So if I've got the equation there, adapting the quadratic formula, then z will equal minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. Simplifying that, minus 2 plus I plus or minus the square root of 12i minus 5 all over 2. Then we get to that and I think, oh, I can't go any further until I can figure out what this is. So just like before, I have to now find out what the square root of, and I probably should write that the right way around, minus 5 plus 12i is. Using the same method as before, and I won't go through it again, we find out that the square root of minus 5 plus 12i should be, our solutions will give us x equals plus or minus 2 and y equals plus or minus 3. So then the equation becomes z equals minus 2 plus I from before, plus or minus 2 plus 3i all over 2. Separating those, that is one of my roots, and the other one is that. So my two answers for z are I and minus 2 minus 2i. You could also check to see if they're right, because remembering from polynomials, the sum of the roots is minus b on a. If I add those two things together, I get minus 2 minus I, which is in fact minus b on a, and the product of the roots, which is c on a, if I multiply those two things together, I end up with minus 2i plus 2, which is in fact c on a.